Hello everyone and welcome to Pepcoding. I hope you all are extremely good. So today in this video we are going to discuss another question on graph, that is the alien dictionary, right? So in this question you are given a list of string from the alien languages dictionary, right? Where the string in words are sorted lexicographically by the rules of this new language. Return a string of the unique letters in the new alien language sorted in lexicographically increasing order by the new language's rule. If there is no solution, return empty string, right? So what we have to do, we are given a string of words, right? For example, we are given these words, that is WRT, WRF, WRT, WRF. Next is ERETT, ERETT. The next word is RFTT, right? RFTT. Now this is the aliens language, that is we don't know any rule about this language, right? So but these words are written in lexicographical order, right? Lexicographical order. Now what is lexicographical order? For example, in our alphabets, that is we know that A comes before B, B comes before C, C comes before D, and so on, right? So if I write a word like AAB and AAC, we know that this word come lexicographically, this word come before this word. Why? Because B comes before C, right? In our alphabetical order, right? In the same way, in similar way, when I wrote ABC and ZEN, right? I know that this word will come before this. Why? Because A comes before Z in alphabetical order, right? In the same way, if I write 1, 2, 3, 4 and I write 2600, we know that this comes before this digit. Why? Because 1 comes before 2 in our lexicographical order, right? So this is what the lexicographical order is, that is the dictionary order, right? So you can say the dictionary order, right? So in dictionary order, if I wrote a word like A, B and Z, right? I wrote another word A, C, A. Now or a, right? Now in ignoring the length of the word in lexicographical order, we ignore the length of the words, right? We just mismatch the characters. Now these two characters are same, right? The first mismatch character is B and C. So in alphabetical order, we know that B comes before C, so this string comes before this. Why? Because first mismatch character of these two strings in B comes before C, right? So we ignore the rest of the characters, right? So this is what the lexicographical order is, that is the dictionary order, right? So if I write a word like hello, right? I wrote another word like hello. Hello. Right, so we know that the we can see that these two characters are same, these two characters are same, these two characters are same. Now L comes before O, so this comes before this in lexicographical order. So we only take care about the first mismatch character, right? We ignore the rest of the string, we just take care of the first mismatch character, right? So these words are given in lexicographical order, right? But we don't know about this language, the rules of this language. So what we have to do, we have to return a string of unique words, unique letters in these words, such that the letters are sorted in lexicographical order, right? For example, so for example, if we see these two words, right? Now W are same, R and R are also same. So T is before F. So we can identify that T comes before F in the lexicographical order of this alien language, right? So we came to a conclusion that T comes before F, right? But why? Because the first mismatch characters are T and F, and T is before F in the lexicographical order. So in the rules of this language, T comes before F if we wrote this string in lexicographical order, right? So we have to return the string of unique letters in these words such that the letters are sorted in lexicographical order. So how can we do this? The first way is that we have to compare the one string with all other strings, and we will identify the lexicographical, the preferences of letters, right? So if I compare these two strings, that is first two string, here we come to a conclusion that T comes before F. So T comes before F, right? Next, if I compare WRT with ER, right? Now W is the first mismatch characters are W and E, and W is before E, so we came to a conclusion that W comes before E in lexicographical order of this language, right? Next, if I compare WRT with ETT, here again the first mismatch characters are W and E. So again we came to a conclusion that W comes before E in the lexicographical order of this language, right? So we came to a redundant conclusion, right? So there is no need to follow this approach of big of n square, in which we are going to compare the one word with all other words in order to find the lexicographical order, right? So this will lead to a redundant solution. So what we are going to do, the better approach is that we will compare the first two words and find a conclusion from this. So we find a conclusion that these two characters are same. The first mismatch characters are T and F, and T is before F. So T must be before F in the lexicographical order of this language, right? Next, if I compare again this word with another, then there will be a redundancy. So what I will do, I will compare the next two words, right? So let's compare the next two words, right? So WRF and ER. So here the first mismatch characters are W and E. So we came to a conclusion that W comes before E in the lexicographical order of this language, right? So if I compare these two words, if I compare these two words and if I compare these two words, so automatically if WRF is before ER, so in the lexicographical order WRT must be before ER, right? So there's no need to compare each time WRT with all the words, then this word with all the words, right? So we can do this by only compare the adjacent two words, right? So next let's compare ER and ETT, right? ER, ETT. So first mismatch characters are R and T. So since ER is before ETT, so we came to a conclusion that R must be before T in the lexicographical order, right? So R must be before T in the lexicographical order, right? Next, the next two words are ETT and RFTT. So ETT and RFTT. So first two mismatch characters are ER and R, and this word is before this, so we came to a conclusion that E must be before R in the lexicographical order. So E must be before R, right? Sorry, E is before R, so the arrow should be like this, right? So what is our conclusion? That the lexicographical order followed in this language is something like this, that W must be before E must be before R must be before T, and T must be before F, right? It is something like this. If I talk about the alphabetical order, the lexicographical order of our alphabets, right? So if I took a word WRT and WRF, right? So since W and W are same, R and R are same, so let's see the lexicographical order of T and F. Since T is before F in this order, so this word must be before this, that is WRT must be before WRF in the lexicographical order, right? So this is how we are going to find the lexicographical order of this alien language, and we have to return this string, right? The unique letters in the sorted order, right? So there's a special case you can say in this, that it may be possible that some letter may not be come in our unique string, right? For example, if Z is here, right? So if I compare these two words, T will be before F. If I compare these two words, W will be before E. If I compare these two words, R will be before T. R is there, right? If I compare next two words, E will be before R. So E will be before R. So we are not able to find the order of Z in this approach, right? So what we can do, we can place Z in any of the place, right? So if I got unique string like this, so we can place Z here. In this case also we are going to get the same string, that is if we are giving a lexicographical order of this in this manner, then we are going to get the same solution if we have to sort these words in the lexicographical order in this order, right? If I place Z here, I got the solution as RTF. If I place a Z here, then also we are going to get the same result if we are given these words and we have to sort them in this order, right? Then also we are going to get the same result. And if I put Z here, then also we are going to get the same result. If I put it here, then also we are going to get the same result, right? So if we are not able to find the lexicographical order of any letter, then we can put that in any of the places. So how can we find it? This you can see that this is something like a graph, right? So we are going to use graph in this, and we are going to use the Kahn's algorithm in order to find the topological order of this graph, right? Topological order. So if you haven't watched the video of Kahn's algorithm, then I suggest you to please watch that video first, because I am going to use the same Kahn's algorithm and I am not going to explain the code again. So if you doesn't watch the video of Kahn's algorithm, then first watch that video and then come to the solution of this, right? So I am going to use the code directly in this question, right? So we are going to draw a graph, design a graph like this, and we are going to apply Kahn's algorithm in order to find the topological order, which will then give us to our solution, right? So let's move to the code part. So firstly we have to design a graph, right? So in order to design graph, I am going to use the hash map, right? So hash map of character and hash set, right? So I am using hash set in order to get the distinct values, right? Next we are going to calculate the in degree of all the letters in the graph, right? So since here we have to calculate the in degree of all the characters in graph, right? In Kahn's algorithm also we are working on in degree, right? So we have to use a hash set in order to calculate to store the in degree of all the characters in the graph, right? So this will be of type it should also be of hash map. So this is of type character and integer, right? Because in degree will be of type integer only, right? So this is what in degree. The name of this should let the name this hash map as graph, right? Next, we have to put the in degree of all the characters to 0, right? So we are given a string of words. So firstly we have to move on each word, right? So first move on each word in the words array, right? Next, in each word we have to move on each character and put the degree of each character to in degree of each character to 0, right? So move on each character. We have to convert this string to an array of character and then read the all the characters of a particular word, right? Put all the characters in the hash map and mark the in degree of all the characters to 0. So in the in degree hash map, put the character C and put the degree as 0, right? So this will create a hash map, right? A hash map and put all the characters in this. The unique characters are T, F and E, right? And mark all the degree in degrees to 0, right? So this is the in degree hash map, right? The next step. Next we have to traverse on each word, right? In order to make our graph, right? So let's traverse in the this array, right? In the string array. Now we are doing what? We are comparing two words. So let's take two words each time, right? So let's name first word as current, which is present at the location I, right? The next word let's name the next word as next, and which is present at location I plus 1, right? So we got these two words, right? So we got these two words, that is WRT and WRF, right? Now we have to traverse these two words until we get the first mismatch character, or first word is lesser than the length of first word is lesser than the smaller word next word, right? Here we are traversing up till here only, right? Why? Because if these two characters are same in alphabetical order, if these two strings are present, then obviously ABC is before ABCD, right? We are matching up till here only, right? So we are traversing the words for how much length? The length of, which is minimum of these two, right? That is minimum of these two. So minimum of, let's use the math.min function, minimum of length of current word and the length of next word, right? Next we have to traverse on these two words until we get the first mismatch character, right? So let's start the traversal on these two words. until we get the first mismatch character. So we want the characters of these two words, right? So we want what? W and W. Next we are matching R and R. Next we are matching T and F, right? So let's store the character in some variables. The first character of the first string. J, right? Next, char C2 is what? The first character of the next string. Right? Next, we are doing what? We are traversing the words until we get the mismatched character, right? So, if C1 is not equal to C2, this means that we got the mismatched character, the first mismatched character, right? So, next what we have to do? We have to add these two characters in our graph, right? So, we have to add T and F in the graph like this, and we have to increase the in degree of F, right? So now there is a possibility that these character out of these characters, this is already present in the graph, right? Now our graph is of type hash map, right? In the key value we are having the character, and in the column value we are having the hash set. In this set all the neighbors of the character are stored, right? All the neighbors, right? For example, if we have something like this, that is R is coming before T, R is coming before F, right? So here it is to R is stored, and here T and F are stored, right? So we have to create one set here. So let's create a set. This set is of type character. Now there is a possibility that this, since we are getting these two, now there is a possibility that this character C1 is already present in the graph, right? So if C1, now the name of our graph is graph, if C1 is already present in the graph, right, then we have to do something else, we have to do something else, right? Now if C1 is already present in the graph, then what we have to do? We will collect all the neighbors of C1 in our set, right? So in set all the neighbors of C1 are stored. Now in the set we will check if C2 is already present or not. In the neighbors of T, if C2 is already in the neighbor of C1, if C2 is already present or not. If C2 is already present, then we have to do nothing. If C2 is not present, then we have to add C2 also. So we will check if C2 is already present in the neighbors of C1 or not. So if C2 is not present, then we have to add C2 in the neighbors of C1, right? Add C2 to the neighbors of C1. And also since we are adding this edge, right? So we are adding this, so we have to increase the, we are adding this, right? So we have to increase the in degree of C2 also, right? So in degree, in the in degree hash set, if C2 is not present, then add C2 and increase the degree of C2 by 1, right? If C2 is already present, take its degree and increase it to 1, right? Next step, now we create this edge, that is this. Now add this to our graph, right? So in the graph, add C1 as the key and add its value, that is set. right? So next, if C1 is not present, that is, if C1 is not already present in the graph, that is in our hash set, then we have to add C1 to the hash set. In C1, since C1 is not present in the graph, then it's obvious that C2 is also not present there, right? So we have to create the set of C2, the neighbors of C1. In that neighbor, we have to add C2, right? So we are creating a set here, right? So if C2 is not present, then in this set, obviously if C1 is already not present in the graph, then C2 will be the first neighbor of the C1, right? So in the neighbor set of C1, add C2 and again increase the degree of C2 by 1 and add this edge to our graph, right? So in this for loop, what we are doing, that we are creating our graph, right? So we are creating this graph, right? Now since we get the first mismatch character here, right, here, so what we have to do, we have to simply break from this loop, so we move to the next two characters, right? So since we got the first mismatch character, so break from this and move to the next two words, right? Now we have created our graph. Now next what we have to do, we have to perform topological sort on this graph by using the Kahn's algorithm. So now we are going to implement the Kahn's algorithm. Again, I suggest you that if you haven't watched the video of Kahn's algorithm, then please watch that video first. Only then you can understand the usage of Kahn's algorithm here, right? So in Kahn's algorithm, we are using a queue, right? A queue. We are going to implement this linked list as a queue, right? Next, also we are doing what, that in the answer we want a string, right? We want a string of unique elements in the lexicographical order. So let's take a string builder object here, which will be our answer. Answer. Let's name this string as answer. Right? Next, what we are doing, that we are moving in the in degree set, right? In degree hash map. Right? So if in degree of an element, if in degree of a character is 0, which means that that character would be the first character in the lexicographical order, right? So since in degree of W is 0, so this would be the first character of our unique string, that is our answer string, right? So add this character to the queue. If the in degree is 0, then add that character to the queue, right? So it is possible that only one of the character can have the in degree 0, right? So put this character to the queue. Here we are only implementing the Kahn's algorithm, right? So we are moving in the queue. Remove the first character from the queue. That is the first character that will be added in the queue. Remove that character. Right? Now add this character to our answer string. Right? Now increase the count variable. Now this count is representing the length of our answer string, right? Now since we have moved here, right, now we want to access this, right? So we'll move in our graph. So what we are going to do, since we move here, we will access the neighbors of this character, right? So where the neighbors are stored in the hash set. So let's take a new hash set of characters that will be representing the neighbors of the first character, right? It is character, right? So please bring the neighbors of this character for me, right? So graph will give us the neighbor of this character. That is the remove from the string, right? Next, we'll move across the neighbor set, right? Neighbors. Let's name this as neighbor. Now since we have accessed this neighbor, now we have to decrease the degree of this to by 1, right? Since we have accessed this neighbor. So decrease the degree of this neighbor by 1. Whatever is the value of this, the in degree of this neighbor, decrease that value by 1, right? Now if the in degree becomes 0, now if the in degree of this becomes 0, now this means that after w, this will be the first character that will now add it to our answer string. So add this character to the queue, right? So after this, check if this in degree becomes 0. Which means that this is now the first character to be added to our answer strings, right? So add this character to our queue. Add this neighbor to the queue, right? Now this queue will help us to get the entire answer string, right? That is WRF. What is the answer string? W comes before WERTF, right? So this queue will help us to get this answer string. So when this queue becomes empty, which means that we have accessed all the characters from our graph, right? So we have accessed all these characters from our graph. Next, we have to check that if this unique string is valid or not, right? Now this unique string is valid only if we have accessed all the characters of this graph. That is, if the in degree, the size of in degree in the in degree hash map, we have access to all the characters, right? So if the count is equal to the size of in degree hash map, then this means that the result is valid, right? So return the answer string builder after converting it to string, else, which means that the no answer is possible for this given string array of words, right? So then otherwise return the empty string, right? So this is our code. In the first for loop we are creating a graph, right? Next we are applying the Kahn's algorithm in order to find the topological order of that graph, right? Again I request you to please watch the Kahn's algorithms video first, right? Only then you will be able to understand this part, that is how we are applying the Kahn's algorithm on the graph in order to find the topological order, right? But there is a Oh, here the spelling of characters is wrong. We are getting some compilation errors. Let's resolve this. Here the value of character, spelling of characters is wrong. In line number 23. Here we are accessing the characters of each word, right? So here word will come, right? Next is line number 72. Here while loop will terminate after this, right? All right. Here I think an extra closing bracket is coming. So let's remove this, right? So let's again try to run this. One closing bracket is missing here. I think this one. There is some mistake of this closing bracket. These two for loops are terminating here. Here we are creating the graph. Next is this while loop is terminating here. I think here a closing bracket. So we are getting the correct answer, right? But if we are going to submit it, one test case will fail, right? So let's understand that test case. That test case is that, let's suppose we are given these two strings, that is abcd, right? So if this string is before this, right? So first mismatch character is d, but the length of this string is greater than this. So if all the first three characters are same, then this string must come before this, right? Only then the lexicographical ordering of these two strings are possible, right? Because if the length of this is greater than this, then smaller word must become before the larger word, right? So if this type of case will come, then we have to return the empty string, that is no lexicographical ordering of these words is possible, right? So this is the input is only wrong, right? So how can we avoid this? So let's create a flag variable, a boolean variable. So take a boolean flag here and mark it to false, right? So when you got the first mismatch character, then mark this flag as true. All right. Next here check that if the flag is false, that is we don't get any mismatch character, and also the length of current string is smaller than, right, or greater than, sorry, the next length of next string, right? Then simply return from this, because the input is wrong, input is given as wrong. It covers this case that if the flag is false, that is if the string is like this, the flag will be false. Why? Because all the characters are same and we don't get any mismatch character. If the length of this is our current, this is our next, And if the length of current is greater than the length of next, then this means that this must be before this, right? So in this case, return from the function. Why? Because the input is wrong, right? So now let's try to submit it. uh, Spelling of current is wrong. Now all the test cases are submitted, right? So what we are doing, we are just creating a graph of this, graph of all the characters, right? Next we are applying the Kahn's algorithm in order to find the topological order of this graph, right? So this will give us the unique the string of unique letters in the lexicographical order of this given language, right? So this is the code. Again, I recommend you to firstly watch the Kahn's algorithm first, only then you will be able to understand this, right? Right. So this is all about this question. Thank you for watching this video.